Students, this question was asked in NEET 2024. There are given assertion and reason. Assertion A tells us that the potential V at any axial point at a 2 meter distance r from the center of dipole moment P of magnitude 4 into 10 to the power minus 6 centimeter is plus minus 9 into 10 to the power 3 volt. Take 1 by 4 pi epsilon 0 is equal to 9 into 10 to the power 9 SI units. A region R is given that V is equal to plus minus 2p by 4 pi epsilon 0 r square. Student. Okay, let us solve this problem. Students, we have studied about dipoles in our theory portion. And what is a dipole, student? A system of two equal and opposite charges separated by a distance is called a dipole. A system of equal and opposite charges. Suppose this is minus q and suppose this is plus q. This may be minus 5 coulomb, this may be plus 5 coulomb, or this may be minus 2 coulomb and this may be plus 2 coulomb. The charges must be opposite in sign and their magnitude must be the same. This forms a system of dipole. Okay, student? They are separated by a distance and this distance is denoted by, student, we know this is called D or this is called 2A when we take the center of the dipole as our reference O, and this is A and this is also A, student. Both the charges are separated at a distance A each from the center of the dipole, so the distance between the two charges is 2A. And what is dipole moment of the this dipole, student? That is defined as a vector P which is equal to Q any charge, okay, any of the charge into D. The distance between them and the distance vector is always taken as a convention from minus to plus. Means this way, this is D. Okay, student? So this is QD, or we may say this is D is 2A, so we may also write this as Q into 2A or twice QA. So we may write its magnitude as P is equal to twice QA. Okay, student? Then we have studied how to calculate the potential due to this dipole at an axial point, at an equatorial point, and at any general point. Here in this question, it asks about an axial point. Axial point means either the point is here, okay, student, in this direction of the axis, this is the axis of the dipole, or here, this may be here along the, in the direction of the positive charge or in the direction of the negative charge. There are two possibilities, okay, student, and what will be the potential of this system, dipole system at this point and at this point? Let us find out. We have already studied it in our theory course, but again, let me do it for you so that you can understand well. Okay, student, and suppose this distance, this is the center and this is the distance. Suppose the point is P, axial point is P, and let this distance be R. The distance of the reference point from the center of dipole is R. Okay, student. So what will be this distance? Distance of plus charge, this will be, this is A and this is R. So this is the distance of plus Q from point P, or point P from plus Q is R minus A, this distance, and the distance of point P from minus Q charge is, student, that will be this R plus this A, that will be R plus A. Okay, student? And what will be the potential at point P? That will be due to the negative charge and that will be due to the positive charge. Suppose due to the negative charge, let it be V1 and this will be V2. So at point P, the potential we may write V is equal to V1 plus V2. Okay, student? And what is then V1? V1 is equal to 1 by 4 pi epsilon 0 q by the distance. What is the distance? that is R plus A. Okay, R plus A, and the charge is minus Q. So we will write it here minus Q and plus 1 by 4 pi epsilon 0, and the charge is here plus Q, and the potential due to the positive charge plus Q at this distance, that is R minus A, will be Q by R minus A. Okay student, this will, we may take this Q is common, 1 by 4 pi epsilon 0 is common, so we may take this outside, Q by 4 pi epsilon 0, and what is inside student? Then this is minus 1 by R plus A plus 1 by R minus A. So this becomes Q by 4 pi epsilon 0, and this is, you take here R plus A into R minus A, R plus A into R minus A, and this will go this side, so this will be minus R plus A, and this will go this side, R plus A. Okay, then this this will be within the bracket, and this minus R will cancel out, and what will this become? This will be Q by 4 pi epsilon 0. This is 2A, and below this is R square minus S square. Okay student, and this distance R, that is the distance of the reference point from a dipole, is very large. It may be measured in centimeter or meter say, but a dipole is a microscopic system. The suppose like an atom student, it is in the range of angstrom. When you compare angstrom, that is 10 to the power minus 10 meter, to centimeter, that is 10 to the power minus 2 meter. This is neglected. A is neglected because R is greater than A. We may neglect this term in the denominator, and we may write this is R square. And what is 2A? 2A is the distance between the two charges, which is called D, and this Q into T or Q into 2A is nothing but the dipole moment of the system. And this is P by 4 pi epsilon 0, and student, this is 1 by R square. Okay student, so we have studied that the potential varies at the inverse square of the distance of the point. We have studied it in our theory portion. Okay student, and we have calculated the potential at this point from the charge plus Q. This point may also be here, I have told you, in the minus Q side. Then this, the sign will be just opposite, because at that time what will happen? If we, the point will be here, the distance from minus Q will be R minus A, and the distance from plus Q will be R plus A. So this sign will change. This will be 1 by R plus A minus 1 by R, leading to, there will be a minus 2A here, and this minus charge, and this will be minus P by 4 pi epsilon 0 1 by R square. Okay student, if the point of reference is taken in the, from the axis of positive charge side, then this will be positive, and in the negative side it will be negative, but the amount or quantity or magnitude is the same. Okay student, so you see here it is given that V is equal to plus minus 2P by 4 pi epsilon 0 R square. So this is wrong, because this will not be 2P, this 2 is wrong. Okay, this will be P, because P is to QD or to QA. Okay student, not QA but to QA, remember always. So this is wrong, this will be 4 pi epsilon, but let us calculate now from this formula it is given. Let us calculate the potential for the point. Okay student, let us see what will be the potential. We found that on an axial point, that will be plus minus P by 4 pi epsilon 0 square, and the distance given here is R is 2 meter. Okay students, so we may put here 1 by 4 pi epsilon 0, and what is given? 1 by 4 epsilon 9 into 10. Okay, and this is 1 by P by R square. R square means 2 square. So this is 1 by 4 pi epsilon given 9 into 10 to the power 9, and into 1 by 4, this 1 by 2 square, and P, what is P? Dipole moment, P or magnitude 4 into 10 to the power minus 6. Okay student, so this 4 cancels out, and this 10 to the power 9 into 10 to the power minus 6, that will be 9 into 10 to the power 3. And what is the unit of dipole moment, student? It is Q into 2D, sorry, Q into D or Q into 2A, that is charge into distance, that is coulomb meter. It is given in here, you see, coulomb meter. So student, this will be 9 into 10 to the power 3. This is given plus minus 9 to the power 10 to the power 3 volt. If it is, suppose this is the dipole system, minus Q and plus Q. If the axial point is here, this will be plus 9 into 10 to the power 3 volt. If this is here in this side, the distance is 2 meter. This is same distance. This is 2 meter and this is also 2 meter from the center of the dipole. But if the point is here in the from the distance of 2 meter in the direction of positive charge, this will be positive 9 into 10 to the power 3 volt. If in the direction of the axis of the minus charge, it will be minus. So this is correct. This assertion A, this is we calculated that this will be plus minus 9 into 10 to the power 3 volt. But this student, this 2 factor is incorrect in region R. So the option A is true, R is false. That is option 3 will be correct, students, for this question.